I'm Ruth Siddal and I'm a geologist. However, my main field of interest is using geological techniques to look at archaeological materials. And particularly, I'm one of the few people in the world who's interested in looking at mortars. And I think a lot of people overlook mortars when you look at a beautiful pavement like this, but actually they're so intrinsic to the construction of this pavement, and without it, it would of course just fall apart. And also the production methodology behind making mortars was enormous. Hundreds of people would have been involved to quarry the limestone, to burn the lime, to cut the wood for the fuel for the lime kilns. It would have been a huge industrial production chain, and I think we tend to overlook this when we're looking at these materials. So I started the survey of the mortars by looking at the whole floor and making a map of it in terms of the mortars. And I was obviously guided as well by the different stones used in various phases of laying of the pavement and restoration. Now, there isn't a huge amount of mortar that's immediately obvious when you look at the floor, but if we bob down and look at this central roundel, we can see quite large areas of original mortars, and we can get some idea of how this must have looked when it was first laid by these pink mortars in the more recent restorations. So to see the mortars here is very, very easy, but if you go to a place like this, we're seeing very, very thin seams of mortar in between the stones, just grouting these stones into place. And basically what we're getting is almost 100% stone. So after I'd surveyed the floor, I had to decide where to take samples, and probably the easiest way to show you that is to show you the different phases of mortar that I found. This is a really good place to start to look at the different phases of mortars used in the floor. This little triangular area is part of the original pavement that was laid down in the 13th century, and we have the original stones and the original mortars, and we call this the primary mix. And if you look at the mortars, they're very orange in colour, and they're actually quite thick grout, half a centimetre or so across in between the various stones. Should probably explain how we're defining a mortar. Basically, you need two main ingredients. First of all, there's the lime, which is made from burning limestone. And then you add the second ingredient, which gives it strength and plasticity, which is the aggregate. And actually these materials are extra special because they have a third ingredient, which is the crushed potsherds. And this is what makes them a coccia pesto. The word coccia pesto literally means pot paste in Italian. But the presence of potsherds is really important because that imparts a reaction within the lime mortars that gives it a hydraulic set, which means it's very waterproof, but also it means it's more strong than a straight lime plaster as well, and actually will set underwater, so they could have actually damped this down to improve the set when they were laying it. So you can see just how well preserved this area has been. I mean, these are quite hard stones, but nevertheless the mortar is in pristine condition as well. If we contrast that with the areas of Purbeck around the edges of this section, you can see how much they have eroded in contrast to this almost perfect part of the original floor. So the technique we use for preparing the samples is standard in geology, and we use it for looking at rocks all the time. And you get a piece of rock, or mortar in our case, you stick it on a glass microscope slide, then you grind it down until it's 30 microns thick, and then you can put another piece of thin glass on top of it, and you have a little slide which you can then put under the microscope, and it's so thin by this stage that it's transparent and you can see through it. And using standard geological techniques that we use for recognising rocks and minerals, we can then identify all the different components present in the mortar, from the cement paste to things that were added like the aggregate and even the potsherds as well. In fact, we can even see what components are present in the potsherds too. So from identifying the different components in the ancient mortars, we can apply that directly to making recipes that replicate these materials as well as possible today. And this is really useful to know as well from, if you like, an academic point of view, because we're seeing changes in the different technologies employed by various workmen and craftsmen over the period that the floor was laid, relaid and restored. So I'm sitting now on the final phase of restoration of the floor, which is Scott's restoration of the 1870s, which was carried out when he was surveyor of the fabric here at Westminster Abbey. And Scott was very, very keen to replicate as best as possible the original primary mix stones and mortars in the floor. So in this area of the Scott restoration, we can see the mortars that he used. And actually probably when he laid these were much more orange in colour than they are now, but during the time of setting and reactions that have happened, they've become a lot paler. So I think Scott probably intended these to be much brighter orange. It seems that Scott was probably trying to experiment with materials to get something that looked right. And he was employing a team of contractors called Poole and Sons, and probably there was some kind of dialogue about mixing one material with another. So they're actually quite lime rich, but probably gauged with things like gypsum and a really unusual set of aggregates like blast furnace slag. You see that was actually quite commonly used as an aggregate at the time. But we're also seeing potsherds as well. So you can see these little orange fragments of terracotta that Scott must have crushed up and added to the mortars that he was using. Scott had clearly looked very carefully at the primary mix mortars, was trying to replicate those in his mixes in the 1870s. So this part of the floor represents what we call the secondary mix, and this was laid down during restorations that took place in the 1660s, towards the end of the 17th century. And here the paviors, the craftsmen who made the floor, tried to use the same patterns that they had seen in the primary mix, but with actually no real attempt to do that. They're using completely different stones, and we can see here as well that the mortars really play a really intrinsic part of the design. And when I analyse these mortars using the scanning electron microscope and also the optical microscope, they have a completely different composition to the primary mix mortars. They're made from gypsum, lime plaster mixes, probably batched about 50-50 or maybe 40-60 gypsum lime. And actually you can feel that they're gypsum rich. They have a very greasy feel to them when you rub your finger over them. The aggregate within them was just pure quartz sand. There were no potsherds or anything, so no effort at all to replicate the appearance of the medieval 13th century mortar. So this part of the floor was laid in the early 18th century, and we call it the tertiary mix. So it was the third major restoration phase. And it's composed of a real mixture of stones, and as you can see, clearly no attempt at all to replicate any of the pattern in the primary and secondary mixes. So just a patchwork quilt of stones, and they're also very, very tightly packed together, so you don't see very much mortar here. Nevertheless, we were able to take a few samples, and these turned out to be, again, gypsum lime mortars with probably 30-40% gypsum, batched to about 60-70% lime, with an aggregate mainly of crushed mineral gypsum added in as a strengthener.